Okay, let's take a second to look at and review inequalities when we're using positive exponents. So let's take the simplest case. X squared is less than 1. Well, x squared is less than 1 if I draw a picture on a number line are all the things between -1 and +1. So a very silly but simple example, if I use -2 and squared it, I'd get 4. So that is definitely not less than 1. So I have to use -1 and square it to get 1. And because this particular example is not a quality, then this actually wouldn't work, but something a little bit smaller than that would work. So -0.999 squared would work. And then obviously the same thing is happening on the right-hand side. So really then what we're talking about is on the number line, x squared less than 1, the picture of that is these things with not including -1 and +1. Okay? So that's what the actual picture looks like, right, on a number line. Okay, so let's take x squared less than 1 and let's do something wrong. So this is not good. So it's a common mistake that gets made is I say then, well, that's the same as x less than plus or minus 1. And that comes from this idea that x squared equals 1. That's what we're supposed to do, right? X equals plus or minus 1 when we have equality. So I did the same thing. It's wrong. This is not good, right? So what this means is that x is less than 1 or x is less than minus 1. And if I draw a picture on a number line, what do I get? So x is less than 1. That is this situation. Or x is less than -1. Well, x and less than -1 is this situation. And this picture then, if I drew out an actual picture, would be -infinity to +1, not including 1. So this picture represents x lying in between -infinity and +1. Clearly not at all the same picture as this one up here. So we're not allowed to just take the square root of both sides and say that's plus or minus. Let's do it correct. So this is good. So before not good, this part is good. So we start with this x squared less than 1. And what do I need that to look like? Well, I need that to look like x is less than 1 and x is bigger than -1. So let's draw that as a picture. So this is x is less than 1, this way. And then this is x is bigger than -1 is this way. And the and means the intersection of those two things. So if I shade in my picture, that's this stuff. Which again is the picture we're looking for up here at the top, right? That's this picture. That picture and this picture are the same picture. So When we're using equality, we're talking about or. When we're using inequalities, we're talking about and. These are different things, much different things. And also the sign, the direction of the inequality switched. So if I write out this statement algebraically, x squared less than 1, algebraically that is x lies between minus 1 and 1. So x is less than 1, that's this part, and x is bigger than negative 1. X is bigger than negative 1. That's that part. And this, by definition, is the absolute value of x, less than 1. So that means, mathematically speaking, that x squared less than 1 is mathematically equivalent to saying the absolute value of x is less than 1. The same exact argument can be used for any even power. So x raised to the 4th less than 1 is mathematically equivalent to the absolute value of x is less than 1, and so on and so forth. By the way, if I had x squared was less than 4, that would be mathematically equivalent to saying that the absolute value of x is less than 2, and so on and so forth. So in the problem that we have from our homework, we have the situation of minus, and then x over 3, all raised to the 4th, take the absolute value, and that's less than 1, because we're looking for the radius of convergence. Because of the absolute value, I can just not worry about that negative sign. So I have the absolute value of x over 3 to the 4th is less than 1. Now, when we're actually working this out on paper, we tend to skip this step, but the step is really there. So this then is x over 3 all raised to the 4th less than 1. By the argument that you mentioned, that this is always positive, right? So if this is always positive, we don't need the absolute value, so we have that. So from that, because of that inequality, I can say that this is x over 3 less than 1, but I need to take the absolute value. Now I tend, when I'm writing this, I write this and go right to that, and I sort of skip this interim step. And then this, of course, is absolute value of x over 3 is less than 1, and then the absolute value of x is less than 3. And then by definition, this is x lies between 3 and minus 3.